Okay, in this recording, we are looking at the decimals homework from Unit 2. We're on question number 25, where Kanita purchased the following items at her local supermarket. 3 blocks of cheese at 7-Eleven per block. So of course, that would be 3 times $7.11. 0.6 kilograms of apples at $1.32 per kilogram. So we take 0.6 times $1.32, noticing that it has the word of here to indicate we should multiply. 5 loaves of bread at $1.27 per loaf. So 5 times $1.27. And 2 dozen eggs at $1.48 per dozen. So we'd take 2 times $1.48. And then we're going to add up the cost of all those items. When we put that into Desmos, we have 3 times 7-Eleven plus 6.6 times $1.32 plus 5 times $1.27 plus 2 times $1.48 is 31 and 432 thousandths. Now, if we're talking about dollars and cents, we need to round that to the nearest cent, which means the hundredths place. This 2 is below 5, so it tells us to leave the 3 the same. So our answer would be $31.43. Now I have a question for everybody, and that is, if you were using the order of operations to do all of this by hand, what operations would we need to do first? We've got some multiplications here and additions.
You first multiply the numbers to the ones in the parentheses, then you add.
Correct. Thank you, Thomas. You would have to do all the multiplications first. So we would take 3 times 7-Eleven, write that down. Take 0.6 times $1.32, write that down. Take 5 times $1.27, write that down. 2 times $1.48, write that down. Then add everything together. Okay, and then if you're doing that by hand, you should be getting $31.43. Okay, so we've got a problem here. Okay, everybody write down $31.43, and then we can discuss it later if there's an issue with that. Okay, also, hi Kenneth, welcome today. Good to see you. If you're in section 510, the attendance code is 2515. And if you're in section 242, the attendance code is 9543. And I'm going to put that in the chat box here in case you didn't catch all of that. I'm not sure which section you're in, which CRN number that's at the top of, it should be at the top of Blackboard. If you look, there's your CRN number. So I'm not sure which one yours is. So I'm just going to put them both in the chat box here. Section 27424. The attendance code for today is 9543. And if you're in section 27510, your attendance code is 9543. So please let me know once you get, sorry, I did that wrong. For section 27510, the attendance code is 2515. Now, for those of you watching the recording of this, don't worry about the attendance codes. This is extra credit just for the people who are here in the session. And there's other extra credit that you can get that's listed in the announcements. The one that's coming up this very soon here is volunteering for the Math for Adults Foundation. So I'm putting the website in the chat box right now. It's at mapsfoundation.com. The first math night that you could volunteer for is September 8th at Atkinson Elementary in Griffin. I do need volunteers for helping with promotions for that event. So if you can't come on the 18th, there's plenty of things that you could do ahead of that leading up to it. Then also you could attend, and you can bring your family, your kids, you know, it's open to the community. So September 25th, there's one at the Gordon State College Library. Then October 2nd is at the Griffin Spalding Library. October 8th is at Moore Elementary, and October 9th is at Callan Road Elementary. So lots of volunteer needs right now. So if you can get extra credit that way if you can't be here in the synchronous sessions. Okay, now I did want to go over, for purposes of the recording here, question 26, the number 967 thousandths would be written as 0.00967, so that your 7 is in the 100,000ths position. And then you can answer the questions as you see right here. Okay, Kenneth, question for you. Have you already taken the Unit 1 test over fractions, ratios, rates, and proportions? And then look in the chat box to see if you answered there. Okay, you think you have. Did you have any questions from the test? It's very important after you take a test that you go into the MyOpenMath, click on Gradebook, and then click on the assessment you took and compare your answer to the answer key to see if I owe you any points back, because sometimes there's a small rounding issue that's that caused you to miss the problem, or maybe the number was 5, but you put x equals 5. I would give points, I would give that back to you. You just email me. So please do double check that. And also let me know if you have any questions about problems that you missed on the test. If you would like, we can go back and look at the specific ones you missed and try to figure out what you did wrong. Just let me know. In the chat box, you can tell me which ones that you want me to go over, and I will. But in the meantime, since both of you have already taken the test, instead of doing a test review today, we're just moving on and talking about the decimals homework. All right, so we have on question 24, 8.82 plus 3.90. Now, because after the decimal point, you have tenths, and then you have hundredths, and it goes on to thousandths and so on. In order to get an accurate sum here, you need to line up your hundredths, your tenths, your ones, and so on, so that you're adding the same place value together. So when you do this by hand, make sure that your decimals are lined up and all of your place values. Now, some people like to use grid paper when they're doing their decimal addition by hand, because it helps you to line up your place values. So let's just quickly do this here. If we add together our hundredths, 200ths plus 0 hundredths would be 200ths. But what about 8/10ths plus 9/10ths? Can anybody tell me how many tenths that would be? Yes, it would be 17/10ths. Now I'm going to write that over here as the fraction that it's representing. it's 17/10. That really means the same as 1 whole and 7/10, because you could break 17/10 down into 10/10 plus 7/10. And of course, 10/10 stands for 1. So it really means 1 and 7/10. So now we can put this 1 whole here with the ones place, and we still have the 7 in the tenths place. That's why back when you were in elementary school, you were taught to carry the 1. It's because 10/10 is the same as 1 whole. So now you just put that 1 whole here in the ones place. Now we have 8 ones plus 3 ones plus 1 1. What's 8 plus 3 plus 1? Somebody give me that. That's correct. It's 12. So we have 12 ones. If we write that as a fraction, we have 12 over 1. Well, this 1 in the number 12, it's standing for 1 set of 10. And so what we do is we put a 1 in the tens place, and we keep the 2 in the ones place. Then we can bring down this 1 set of 10, and we're left with 12.72. Another way to think of this 12 over 1 is to think of it as 10 sets of 1 plus 2 sets of 1. So that gives us a 10, 110. So we have a 1 in the tens place in terms of place value. Now, of course, we could have done this in Desmos and done 8.82 plus 3.90. So there's our 12.72. Another thing that I encourage you to start doing in all of the math problems that you're doing is do a quick estimate in your head to make sure that your answer is coming out close. So if we were going to estimate this, 8.82 is pretty close to what number? Yes, pretty close to 9. How about 3.90? Kenneth or Thomas? What whole number is that pretty close to?
4.
4. So in your head, if you're doing 9 plus 4, how much is that? Thank you, Kenneth. It's 13. We got 12.72. Is that pretty close to 13? Yes, it is. So we can assume that our answer is pretty close to whatever the correct answer is, because it's close to 13. Now, if you ended up with an answer that was 172.2, that you know it's supposed to be close to 13, you can quickly correct yourself and say, hey, I know that this isn't, it's not even close. It's not right. So when you're on a test, estimating can help you decide if you're close to the right answer. Okay, do we have any questions there on that decimal? Now, remember, you are allowed to use Desmos on the test. You're also allowed to use your 4-function calculator or your scientific calculator that are on your cell phone, but you can't use any other apps besides those. So if you are having a proctor watch you while you take the test, those are things that they are watching for, that you're using the authorized resources, You can use Desmos, you can use your four function or scientific calculator, you can use scratch paper, you can use a note card that's handwritten by you. No other resources though. No notes, sheets, no texting, no looking anything up online. Just those authorized resources. And if you do use a proctor, so you do line somebody up to watch you take the test, it's a 5% bonus on the test. They just email me that you use the authorized resources and I add 5% to your test score. So you might want to think about doing that when you take your next test. Okay, question 22 says use the order of operations to simplify this expression. So who can remind us all what is the order of operations? Starts with a P. P stands for parentheses, then what? So Thomas, Kenneth, oh, thank you, Kenneth. You put it in the chat box. I didn't even notice it. You're correct. Exponents. So you do what's inside of any parentheses if you can. Do any exponents you can. Then what? Yes, then we do the multiplication and division left to right. If you have both, you don't do the division first or the multiplication first. You just go left to right. And after that comes adding and subtracting, again, going left to right. So in this problem that we see here, I see there's an addition. I see there's a multiplication. When you have a number right next to a percent parentheses like that, it means multiplication. Then in the parentheses, we have this subtraction. So what should I do first? Correct. We need to do the subtraction, which is in the parentheses first. Now remember, when you are adding or subtracting decimals, well, you tell me, what do you have to remember to do? Which is the correct way of writing this problem, the first way or the second way? So in the setup of the problems, which one have I set up correctly? I mean, I know, I agree. They're both 11.5 minus 8.2. You can do them both in your head. But if you are having the correct setup in terms of place value, which one is set up correctly and why? Setups are not the same. I'm really thinking about the placement of the decimal point. What is correct about one of them and incorrect about the other?
The correct one's on the left, the incorrect one's on the right because the decimal points have to line up.
They do. You need the place values to line up. So you need the tenths, the ones, and the hundreds to all line up. So 5/10 minus 2/10 would be 3/10. And then you can think of this as 11 minus 8, which we know is 3. Or you can look at it as a 1 minus an 8. We couldn't do that without going into the negative, so we can do a trade here off of the tens place. We can call that 10 ones and put the 10 ones with the 1. So 10 plus 1 is 11. 11 minus 8 is 3. Some people would do it by taking the 8 off of the 10 right here, which would be 2, put the 2 with the 1, and it gives you the 3. So there's several ways of doing that mentally. So this parentheses right here is 3.3. So according to our order of operations, we've done the parentheses piece. Are there any exponents that we have to deal with? Are there any exponents in this expression that we have to take care of from the order of operations? Thank you, Kenneth. There are not, so we can skip over that. Is there any multiplying or dividing that we have to deal with? Yes, there's multiplying. We need to do the 8.5 times the 3.3 before we do the adding. If you did 6.4 plus 8.5 and then multiplied, you wouldn't get the correct answer. It wouldn't be the same. Let me show it to you. If we have 6.4 plus 8.5, and then we take all of that, the 14.9 times 3.3, we get 49.17. But if we do the multiplication first and we do the 8.5 times the 3.3, and then we add that on to the 6.4, we get 34.45. You can see it's two different answers. And mathematicians have made the judgment call. They say it makes a lot more sense to follow the order of operations where you do your parentheses, then your exponents, then any multiplying and dividing left to right, then you're adding and subtracting. So if we do that, we'll get the 34.45, and Desmos, it's built into the programming of the Desmos calculator that it uses the order of operations. So if we put all of this into one statement, it'll get it right. So if we do the 6.4 plus 8.5 times 3.3, there you get the 34.45. That's why I encourage you to use Desmos on your homework and your test instead of just your 4-function calculator, because there's some little junky 4-function calculators like this one that I have here. I can find it. I have a little, I think I probably got it for like $1 at a thrift store or something. And it does not do the order of operations for you. Here it is. I don't know if you all can see my screen. So let me just see what happens if I pop it into this little cheap calculator. I actually think this calculator was attached to a tape measure. I've been doing a lot of renovations in my house. I probably thought it was cool to have a calculator and a tape measure together, but it's really a pretty junky one. If I do 6.4 plus 8.5, and then hit my times button, it's already added the 6.4 and the 8.5. then take that times 3.3 and hit equals, it gives me the 49.17, which is not correct. It's not the right answer. The right answer is 34.45. So this little cheap four function calculator, actually it does a little bit more than four things. It has a square root, it has a percent. But anyway, it doesn't have order of operations built into that. If you only had access to that little calculator, you as the thinking person would need to take the 8.5 times the 3.3 first and then add it on to 6.4. Okay, so I hope that is helpful to you. I know there's a lot of people in this class that are in the construction trades, in industrial systems, welding, things like that. Just be aware that if you've got yourself a cheap little calculator, you have to do the order of operations in your brain along with using the calculator as a tool. Or use the Desmos app on your phone. It's a free app that you can get from your app store. Here it is on my phone. And use that. Any questions on that problem before we move on? All right, next we have a multiplication question, but I'm going to skip over it for right now because here's another subtraction question, and we were just talking about subtraction. So let's go ahead and do this. We have 1.1 minus 0.779. So let's make sure that we line up our decimal places. There's our 1.1 minus the 0.779. And I know we can throw this on the calculator, but right now we're trying to look at the reasoning and the structure behind it so you have a better understanding of what place value and what it means. So this stands for 1 whole and 1/10. There are not any hundredths or thousandths. So we just put zeros in those places as placeholders. So this is standing for 1 whole and 100 thousandths. And we're going to subtract off 779 thousandths. Now we could do this with all of the trading and everything, but to me, there's an easier way to do this. What I'm going to do is just put this over the denominator of 1,000 because we have our last digit in the thousandths place. So this, the 1.1 actually stands for 1,100 thousandths. And we're going to subtract off 779 thousandths. So if we wanted to do this in our head to get our answer in the thousandths, is anybody able to take 1,100 minus 779? Everybody try to do that in your head. 1,100 minus 779. And either put in the chat box what you got or unmute yourself and just say what you got. And we'll see if we all got the same thing. I've just done it in my head. I think I know the answer if I haven't made a mistake. Okay, we have one person. Yes, I agree with you. Thomas and Kenneth, have either of you gotten it? Is anybody getting 321 thousandths? So if I'm correct on that, the 321 thousandths, if my mental math is right, then our answer is 0.321. Now let's check my math using the algorithm. We can't take 0 minus 9 without going into the negatives. Can't take 0 minus 7 without going into the negatives. We can't take 1 minus 7 without going into the negatives. So we're going to need to do a trade here. 1 whole is the same as 10 tenths. So we're going to put a 1 in front of this other 1 in the tenths place. So now we have 11 tenths that we would be able to subtract. But let's do some more trading here so we can get some values in the hundredths and the thousandths places. So we have 11 tenths. If we take off one of those tenths, it's going to give us 10 hundredths. So that just leaves us now with 10 tenths. We have 10 hundredths, and we'll do a trade here, leaving us with 9 hundredths and 10 thousandths. So now we can do our subtraction. 10 thousandths minus 9 thousandths is 1 thousandth. 9 hundredths minus 7 hundredths is 2 hundredths. 10 tenths minus 7 tenths is 3 tenths. And we completely traded off our whole number. So we get 0.321. Let's also check this over in Desmos. 1.1 minus 0.779. Is 0.321. Now, I'd like to know your preference. Do you prefer, if you had to do it by hand or in your mind, do you prefer turning it into fractions and taking the 1100 minus 779 and get 321 thousandths? Or do you prefer doing the trading? Thomas and Kenneth, what's your preference? Do you prefer doing it mentally, where you turn everything into thousandths and call it 1100 thousandths minus 779 thousandths, or do you like the trading method? You can put it in the chat box or just unmute yourself. Trading. It's probably more familiar to you. It's typically what's taught in school. When I was young, when I was in school, they taught us, they called it borrowing. Now they use a better word. They call it trading, because that's what you're actually doing. You're trading out ones for tenths, hundredths, and thousandths, and so on. Okay, so let's go back, verify that we got that one. All right, now we have a multiplication here. The shortcut for multiplication is it's kind of it's really slick. I like it. So let me just write these numbers in terms of their fractions first. So we have 6 2/10. That stands for 62 tenths. And here we have 5 61 hundredths. In other words, that's written as 561 over 100. And now you take the 62 times the 561 and multiply those whole numbers. I'm just going to throw it on Desmos. So that's 34,782. Because when we multiply fractions, we do numerator times numerator, denominator times denominator, 10 times 1,000. When you're multiplying powers of 10, when you have the zeros at the end, you do your multiplication and put on that number of zeros. You just ignore the zeros at first, multiply your whole numbers or your other numbers, and then put on the zeros. Now we have 34,782. We count how many zeros we have. It's 3 zeros. So we're going to multiply, or we're going to move our decimal back 3 places is the shortcut way here of dividing by 1,000. So we have 34. We move back 3 places. It would be 34.782. And if you want me to show you that on Desmos, taking your 34,782 divided by 1,000, you can see how it moved the decimal back 3 places. But the shortcut is you just move it back 3 places. Okay, now let's think about our original problem and compare it to this here to see the shortcut. We had 6.2 times 5.61. First of all, the shortcut is just ignore your decimal places and multiply the whole numbers. Well, we did that here. 62 times 561 was 34,782. And then you move back by however many decimal places there were. So I see there's 1, 2, 3 decimal places in this problem. One of them is from the 6.2, 2 of them is from the 5.61. Move back 3 decimal places, boom, boom, boom. There you have it, 34.782. So what we did here shows you the reasoning behind that shortcut. The reason you can just multiply the whole numbers and ignore the decimals is you're putting the whole numbers over the place value, whatever power of a 10 is appropriate. So that's multiplying the whole numbers. And then you divide by the product of those powers of 10. However many zeros you have, that's representing how many place values you have here. And then you just move your decimal that many places back. Okay. So of course you can do it on Desmos, but that's the reasoning behind the shortcut that you maybe learned when you were in school. Okay, and let's just check our answer here, 34.782. We got it right. Any questions on what we did there?
No.
All right, we're skipping 19. It's another subtraction one. We've done that type. Okay, let's do the division next. We have 88.55 divided by 11.5. So when you were in school, you'd probably learn to write it like this. 88.55. And then you did divided by 11.5. And then the rule was to move your decimal to the right 1 place to turn the 11.5 into a whole number, 115. And then you also had to do it to this number right here. So it turned into a division problem that looked like 885.5 divided by 115. So you moved your decimal place 1 place here, and then you had to be consistent and move it 1 place here. And then you did your long division, asked how many times. Does 115 go into 8? None. How many times into 88? None. How many times does 115 go into 885? You brought your decimal up and you continued with that long division. Now I'm going to show you why you did this setup the way you did it. Why could you just move your decimal one place on both of those numbers to have it come out to be a whole number as your divisor? Well, again, we can put our decimals in terms of fractions. 88.55, you could write as, well, let me just go like this. I'm gonna write the problem. 88.55 divided by 11.5. We can write it as a fraction. That fraction bar means divided by 11.5. Now, we could multiply both numerator and denominator by the same thing, and it'll keep its same value. Okay, remember when we simplified fractions, we divided by the same thing? In both the numerator and the denominator, well, you can multiply by the same thing in the numerator and the denominator, scale the whole thing up, and you have an equivalent fraction. It's just in a different format. So if we multiply both the numerator and the denominator by 10, we end up with 885.5 over 115, which is what we had, what we have right here. When you move your decimal one place to the right on both numbers, it's really multiplying both of the numerator and the denominator by 10, and the actual answer, the quotient, which is the answer to a division problem, won't change. And then, of course, you continued on with the long division. I'm not going to do that in the interest of time. We'll just go in and finish this off in Desmos. 88.55 divided by 11.5, and the answer is 7.7. If we had done it with long division, now that I see the answer, I can see this would have been a 7. 7 times 115 is 805. So we would have put 805 right here. Then you brought down this 5 and did the subtraction. 5 minus 5 is 0. 8 minus 0 is 8. 8 minus 8 is 0. Then you asked how many times is 115 go into 805. The answer was 7. 7 times 115 is 805. Then you subtracted, and there was no remainder. If there was a remainder, here you would put a 0 here, bring it down, and continue saying how many times does 115 go into that number, and so on. And then if you wanted to stop at some point, you can take your remainder and put it over 115. But for purposes of this class, you are allowed to just do it on Desmos and take your 88.55 divided by 11.5 and get 7.7. Okay, here's another multiplication. If you were doing it with the shortcut, you would take 357 times 393, and then you would move your decimal back 4 places because you got 4 decimal places here. Again, you want to check, just do a quick estimation and see what it's going to be close to. So 3.57, I might round that close to 4, 3.93 close to 4, 4.4 times 4 is 16. So I'm going to predict my answer is close to 16. And here you see it's 14.0301. Okay, we've done a subtraction. Here's adding decimals. Right, 0.105 is a fraction, and then we're supposed to reduce it. The better word for that is simplify, because we'll get an equivalent number. 0.105 ends in the thousandths place, so we're going to write that as 105 over 1,000. Can anybody tell me what is a common factor that I could divide out of both 105 and out of 1,000? Pull up the chat box in case you're putting it there. I need a common factor. What's a factor that's in common between 105 and 1,000? What are they both divisible by? There's a number in common. Kenneth or Thomas, anybody see a number in common? We could divide out of both 105 and 1,000. Simplify it. I would agree, Kenneth. 105 divided by 5 would be 21. And 1,000 divided by 5 would be, let's see, 100 divided by 5 is 20. So 1,000 divided by 5 would be 200. And 21 only has factors primes of 3 and 7. 200 is not divisible by either of those. So we know that we're finished simplifying. Okay, write 944 as a mixed number reduced to lowest terms. 944 is already a whole number, so you just say 944. If you had a harder mixed number to turn into a let's see, if you had a harder decimal that you had to turn into a mixed number, like let's say you had 944.1, you would turn that into 944 plus 1/10, because that 1 is in the 10th place. Then you would need to get a common denominator. So this is 944 over 1. So we need to multiply that times 10 over 10 in order to get the same denominator. So this is going to be 9,440 plus 1 after you take in the 944 times 10. So we're going to have 9,441 all over 10. And that is in simplest form. To write 8/9 as a decimal, rounded to the nearest thousandths. Just remember that your fraction bar means divide. So we go in here and we take 8 divided by 9. And if we're rounding to the nearest thousandth, you look in the 10,000th place, this 8 would tell that 8 to bump up. So we would have 0.889. You're writing this decimal in words. Remember that when you have the decimal point, you're going to use the word and. So we have 790 and then you look at where your number ends, what decimal place. Since the 9 is in the hundredths place, you're going to call this 790 and 39 hundredths. Okay, so we've covered all the types of problems in the decimals homework. I want to thank everyone for being here. You're free to leave. I'll stick around if there's anybody that has any individual questions that you would like for me to answer. So thank you for your hard work. Thank you for working ahead and taking the test already. I appreciate that, and I'll look forward to seeing you next week. Bye.